You may have noticed that devices on the same network have IP addresses that share a prefix. That is, they all start the same and only differ after some particular bit position. Devices on the same network have the convenience of communicating with each other without needing to use a router. Now, not all networks are the same size. Think, for instance, about the size of a network that a small business would have and compare that to a large college network. The college network would have several orders of magnitude more users than the small business. To accommodate this, each network can select an appropriate prefix length. A network with a longer prefix, say 24 bits, would have less of the address left over to distinguish individual devices. To state the size of a network, it is common to write the number of bits in the prefix after the IP address, like so. Let's calculate how many individual IP addresses there are available on a /24 network. With 24 bits taken up by the prefix, 8 bits are left for addresses. 2 to the power of 8 is equal to 256, and so that's 256 addresses. You may have guessed that one already. Of these 256 addresses, the first and last ones are usually reserved, and the second address commonly belongs to the router. So that leaves us with 253. If we look at a /16 network, 16 bits of the address are dedicated towards the prefix, and 16 are left for individual addresses. A /16 network has 2 to the power of 16 individual addresses, which is just over 65,000. Once again, the first two addresses and the last one are reserved. Can you do the math? How many individual addresses are there in a /22 network?